Hi, this is Sarah Razanfari. In this video, I'm going to talk about question number 1 of homework 6 of probability and stochastic processes course. Let's go to the question. In this question, we have a joint density function, and in the first part, we want to find A such that the f of xy is the valid density function. So we know that for a density function to be valid, we should take the integral of its range of variables, and this integral should be equal to 1. So at first, I will calculate the integral with respect to x. So 1 turns to x, and xy turns to x to the power of 2 divided by 2 times y. After putting the 1 and minus 1 into this formula, the part which contains a y is going to be removed, and then we should take the integral of 2 with respect to y. So we will get to 2 times y divided by a, and this should be equal, after substituting the ranges, this should be equal to 1, so a is equal to 4. Let's go to part 2. In part 2, we are asked whether x and y are uncorrelated or not. So to answer this question, we should first calculate the expectation of xy, and then we should calculate the expectation of x and the expectation of y. And if the expectation of xy is equal to the expectation of x times expectation of y, x and y are uncorrelated. And if this is not, x and y are correlated. So as I mentioned, I will first calculate the expectation of x times y. So we have the joint density function, and so we can write down the formula x times y times the f of x and y. And first we'll calculate the integral based on x with respect to x, and then we should substitute the ranges for x into the formula, and then we will do the same thing for y, and then we will get to the answer, which is 1 divided by 9. And for expected value of x, we need to calculate the integral with respect to x for x times f of x. And because we don't have f of x, we should first calculate f of x. And for calculating f of x, we should calculate the integral of f for x and y with respect to y. So we should first calculate this integral so that we can have f of x. And after doing that, we can calculate our integral based on x, and we will get to 1 divided by 2. So let's calculate the last term, which is the expected value for y. Again, we don't have the marginalized distribution for y, so we're going to first calculate f of y, which is the integral of f of x and y with respect to x. And then after doing some calculations, we will get to 0. So obviously, e of xy is not equal to the e of x times e of y, so x and y are not correlated. And let's go to the other part. The third part, we are asked whether x and y are independent. So if x and y are independent, we should, so if f and x are, if x and y are independent, then f of xy is equal to the f of x times f of y. And so from the last part, we've calculated f of x and f of y, and when we calculate f of x times f of y, we see that these two terms, this term, which is which is a joint distribution, joint density function, is not equal to this. So they are not independent, they're dependent. And let's go to part 4. Find the joint density function of x to the power of 2 and y to the power of 2. Let me check that my video is going on. Yes, so let me get back. So, okay. In the last lecture, we learned how to calculate the joint density function of z and w, and we can define z as x to the power of 2 and y to the power of 2 for w. And then we should calculate x and y with respect to z and w. And then we should calculate the Jacobian matrix, which is partial derivative of z with respect to x, which is 2x, and partial derivative of z with respect to y, which is 0, and the partial derivative of w with respect to y, with respect to x, which is 0. And then we should calculate the partial derivative of w with respect to y, which gets to this matrix. And then we should calculate the determinant. And here is the determinant, and we have the x and y, so we will substitute these two values in this, and we will get to this value. And after that, we should substitute the values of x and y in the formula which we have here for f of x and y. So let me get back to my answer. And yes, so here we calculated the joint distribution function, the joint density function of z and w, and as you can see, these are independent of each other. So f of x to the power of 2 and y to the power of 2 can be derived from this formula by just substituting z and w with their values which we have here. So, okay, let's go to the last part, that we are asked to say whether x2 and y2, x to the power of 2 and y to the power of 2 are independent. So we can see that so if we calculate the marginalized density function with respect to z and w, we will see that the f of z multiplied by w, the f of the joint distribution of z and w is equal to the marginalized of each one times to each other. So we can understand that x to the power of 2 and y to the power of 2 are independent. Okay, that was answer to question 1. Thanks for listening.